Hello students, good afternoon. Welcome to Visionary Tech YouTube channel. I hope you are all doing well. Today we are going to discuss a new concept that is called Python NumPy. Okay. First, let me share the screen and explain. Yeah, I guess screen is visible to you all. Let me give some brief, simple overview on NumPy. See, basically NumPy is a core Python library used for solving mathematical calculations. It has some set of functions used to operate on different kinds of array. NumPy full form is numerical computing. It is more inclined towards, it is more useful towards solving different kinds of mathematical operations and calculations. Okay. Basically it is more faster than list and less memory consumption compared to list. Um, let's see different kinds of operations on NumPy. See here one more difference between list and NumPy. List, there is no specific module to import in order to work with list, but when we are in order to work with NumPy, we have to import a specific library called import NumPy as NP. First we have to type import NumPy as NP. NP is a short form of NumPy, that you should remember always. So import NumPy as NP. This is the first thing. First, in order to create any NumPy array or in order to perform any NumPy operation, first this library should be imported. Then only we can perform different operations using NumPy. Okay, first operation, create NumPy 1D array. We are going to create one-dimensional array using NumPy. For that, n1 is for that we have to take one variable, that is n1. You can take any variable you want. I took n1. N1 is equal to np dot array. You see, this is normal parenthesis, inside square bracket 1 2 3. Okay, since it is for 1D array, here only one square bracket. This is 1D array. After that, we have to run this, and in order to check the output, see 1 2 3. We can check data type also. See nd array means this is a NumPy array. This indicates now it is a NumPy array. Okay. Let's see 2D array. 2D array. Here I have to n2. N2 is equal to np dot array. Okay. Here we are declaring two square brackets. One is for opening, one is for closing in between elements. So we have to take here two square brackets. One is for opening and closing, one is for storing elements. Okay, since it is 2D array, we are taking like this. See 1, 2, 3, 4, 5, 6. Again, into 1, 2, 3, 4, 5, 6. First we have to run this. Yeah, I'll run and show. Yeah, 1, 2, 3, 4, 5, 6. Okay. Next, check shape of NumPy array. Check NumPy array shape. Okay, I'm taking a new NumPy array n3. N3 is equal to np dot array. Here I have given some certain elements 11, 22, 33, 44, 55, 66, 77, 88. Okay, these are the elements stored. Now n3 dot shape. See, here it is showing that it has 8 elements. Okay, since here only 8 elements stored, it is showing it as 8. Now I want to reshape NumPy array. See, 8 means 1 into 8 is 8. Same way 8 into 1 is 8. Now I want to reshape this NumPy array into 2 cross 4 matrix. 2 into 4 shape. 2 cross 4 matrix. See, here it is, that's why it is displayed 2 rows, 4 columns, 2 cross 4 matrix. It is displayed in the form of 2 cross 4 matrix. Okay, this is about reshape. NumPy with zeros and ones. NumPy with zeros and ones used to store required number of times we can store, like we can create a matrix of zeros and ones, with required number with required shape, basically. Yeah, let me explain it again properly. Sorry. See, NumPy zeros used to create a NumPy array or NumPy matrix with zeros. NumPy ones used to create a NumPy array or NumPy matrix with ones. See here, in order to create zeros, here I have took a variable n4 equal to np dot zeros 3 comma 3, means 3 cross 3 matrix. That is why here the elements are also displayed. Zeros are also displayed in 3 cross 3 3 cross 3 form. That is why here 3 columns 3 rows. Same way, n5 equal to np dot ones. Now I am going to create a 3 cross 3 matrix of ones stored. Okay, 3 cross 3 NumPy matrix. Okay, I didn't run here. N5 equal to np dot ones. Wait, n5. See, all the elements are displayed. All the ones are displayed in 3 cross 3 format. Okay. Now, I want to store a specific element in this 3 cross 3 matrix. You can take any shape if you want. I took 3 cross 3. So, numpy dot full. This is used to display a specific element in a required form or required shape. See, here it is in a 3 cross 3 matrix form. Now in this 3 cross 3 matrix, I have displayed all the elements as 6. This is possible using numpy.full command. numpy.full command. Now, numpy stacking. Okay. Generally we have two types of stacking operations, vstack and hstack. Okay. For that, I am creating two separate numpy arrays, two separate numpy 2D arrays. Okay. These are two separate numpy 2D arrays. Now, first I want to check vstack, vertical stack. See, the elements are displayed in a vertical fashion. Now, horizontal stack. The numpy arrays are displayed. The numpy array is displayed in a horizontal fashion. This is about stacking operation. VStack used to display in vertical fashion. HStack used to display in horizontal fashion. Okay. Next, NumPy arithmetic used to perform arithmetic operations in NumPy array with NumPy array. Used to perform arithmetic operations with NumPy array. What is arithmetic operations? Addition, subtraction, multiplication, division. Okay, let's create one more array. N11 is equal to np dot array. I have declared 4 elements, 22, 33, 44, 55. Okay. Now I am taking separate variable. N12 is equal to n1 plus 5. Plus means addition. So n12 is equal to 27, 38, 49, 60. Okay. This is the result of addition. And again, n13 is equal to n11 minus 5. See, n13, 17, 28, 39, 50. See, this is the result of subtraction. Again, n14 is equal to n11 into 2, means this is the result of multiplication. That is why we are getting 44, 66, 88, 110. Okay. N15. N15 means what? N15 is equal to n11 by 2. n11 by 2 means what? Division operation. Now n15. So 22 by 2, 11. 33 by 2, 16.5. 44 by 2, 22. 55 by 2, 27.5. This is the result of division. Okay, now line space. Imagine I have to get 10 elements from this range 2 comma 20. Out of this 2 to 20, there are 18 elements, including sorry, two yeah there are 2 to 20. This is a range. This is a range. From this range, I want to get 10 elements. See, source, destination, step. source, destination, step. From this 2 and 20 in between, there are many elements. From that, I want 10 elements. That's why here we are getting 10 elements. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. This is about line space. Basically, this is a range. Actually, np dot line space, we are giving the range, elements range. This is a minimum element. This is a maximum element. In this range, we want 10 elements. N16. So if we give 10 elements, we'll get 10 elements. That is 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. This is about NumPy line space. Okay. So we discussed NumPy creating of 1D array, creating of 2D array, shape, reshape, stacking operations, arithmetic operations, line space. Let's see if I forgot anything. Yeah, zeros and ones and full. Hope you understood all these operations. Next video will be part 2 of this NumPy series. Hope you like my lecture. If you like my lecture, please like, share, and subscribe to my channel Visionary Tech. Thank you.